Okay, first we're going to start with doing some review. We're going to start by working on practice 2 and we're going to work on the odds. Remember the last couple classes we've been talking about inequalities, the idea that we want to find all of the values that make some sort of inequality true, something that involves a less than or a greater than and the equal to. So starting with number 1 here, when I go to graph an inequality, first of all I notice it's an inequality with a symbol that's involved. I read the symbol carefully. Looking at this symbol, I see that it forms sort of an L. Again, if you turn it sideways, it looks like an L. This is a less than symbol. The line underneath says that it's less than or equal to. So the first thing I ask myself is, what type of point should I use? So hopefully you've made that decision in your mind. The type of point for an inequality like this is a closed circle because of the equal to. That means we include the point or the value -1/3. So at the point -1/3, I'm going to draw a closed circle. Okay, then the symbol says less than or equal to. Less than, I want the values that are smaller than -1/3. So values that are smaller are -1, -2, any value to the left. So I'm going to shade this graph to the left. Okay. Continuing down, I'm going to go to number 3 because we're just going to work through the odds here. Now I look at this inequality and I see that we have x is less than again, but no equal to this time, 4. So without the equal to again, I think about what type of point I want to use first. Hopefully you thought open circle. And now I want to shade indicating all the values that are less than 4. So again, this is taking me to the left. Okay, those were our basic inequalities, where we had a single inequality. In the focus, we saw this idea of compound inequalities, where there's more than one inequality involved. So this is what we looked at yesterday. The first one is what I call sandwich inequality. There's 2 inequality symbols, one x, and the x is in the middle. If the x is in the middle, it's indicating that you want to find all the values between the 2 other inequality states. So here, as I look at this, I'm seeing I want to find all the values between -2 and 4. Some of the details I need to pay attention to, again, is what type of circle to use at those points. Here it's saying -2 is less than or equal to, so we're including -2. So at -2, I want to put that closed circle. And then I want to go all the way up to 4, but I don't want to include 4 because there's no equal to, so I'm going to put an open circle there. And then I want all the values between. The next odd involves a compound inequality again, but this time it's written with 2 inequalities and the word or. Keep in mind, let's not forget that the word or means either one. I want every number shaded that is a solution to the first inequality or the second inequality. So the first inequality says I want all the x values that are greater than 5. So let's go ahead and take a moment and draw the graph of that. It is greater, it's trying to eat the x, so that's the greater symbol. There's no equal to, so we're going to put an open circle at 5. And remember when we did these, we started by just giving a little quick which direction to go. We'll analyze at the end. So this one, greater, that means I need to go to the right, a little bit off of my graph. The second inequality says x is less than or equal to -2. So it's got the equal to, so we're going to put a closed circle. Less than means I need to go smaller, so I need to go to the left. Okay, so that's the basic. Now let's think about it a little more carefully. The word or says either one. So I got to shade everything that makes this true as well as everything that makes this true. So I'm going to go ahead and draw in the graphs that I have indicated. This is the less than -2, so I'm going to go to the left that way. And this is the greater than 5. So I'm going to go to the right. Anything that's in either one of those shaded regions is a solution to this compound inequality. As we continue on, here we're talking about values instead of drawing a graph. Number 9 asks which of the values are in the solution set. Remember, solution set just means all of the answers. For the inequality -4 is less than or equal to x, which is less than 1. That's how we read those. And what they're telling me, and what this is indicating, is I want all the x values that are between -4 and 1. So I need to take a look at the x values that I have. the values that I'm asked to work with. Square root of 2. If I take a moment and put that in my calculator, I get the value of 1.41. Okay, let's look and make sure we have everything else that I can work with, and we'll circle. Fractions we have a little bit of trouble with, so it's helpful to put those in our calculator as well. If I put 5 over 2 in my calculator, I get 2.5. Okay, now these are in forms that I can actually work with. So trying to figure out what's between negative 4 and 1. Is 1.41 between negative 4 and 1? Actually, it's larger than 1, so it's outside of this set of values. So that's not a solution. Negative 4? Is negative 4 between negative 4 and 1? Well, maybe. We have to be careful because it's at one of those endpoints. But I see the equality there, so I'm actually looking for anything that's greater than or equal to negative 4 and also less than 1. So negative 4 is in that solution set because of that equality. 2.5? 2.5 is bigger than 1, so that's not in that solution set. 1? Again, it's one of the endpoints, so I have to be careful. If I look here, I see there's no equal to. So this 1 is not in the solution set. 0.33, that is less than 1 and it is greater than 4 or negative 4, so yes, that is in our solution set. Negative 2.2, that's greater than negative 4, it's less than 1, that's in our solution set. 3 is bigger than 1, so it's outside of our solution set. So only these 3 values of the ones we're given are part of the solution set for this compound inequality. Okay? And then our final odd is number 11. It is an OR statement. We have 2 inequalities. I want to know all the x values that are less than 1 or greater than or equal to negative 1. So I'm going to go ahead and again draw these in their most basic form, and just a quick sketch of that without drawing the whole graph first, and then take a look at what I have. So x is less than 1. I see no equal sign, so I'm going to put an open circle. Less than means I want all the smaller values, so that goes to the left. I want to be greater than or equal to negative 1. So greater than or equal to means close circle at negative 1. Greater than means I go to the right. Okay, a lot of us are tempted at this point to shade between, but we need to make sure we're careful about that. This is an OR graph. OR means either one. So if I think about the area that contains a point for either one of these inequalities, I'll see that something unusual happens. If I think about these values over here, let's say negative 3. Negative 3, that's less than 1. Negative 3 should be part of my solution set. It's shaded by this graph over on the right here that continues all the way to the left. 3, well, that's not less than 1, but it is greater than or equal to negative 1. Because this says OR, I want all the values that make either one of them true. Ultimately, this one's going to shade all the way to the right. This one's going to shade all the way to the left. And what happens is we get the whole number line shaded. All possible values make this inequality true. There's no value of x that I can come up with that does not make this inequality true. Okay, these are special cases. They're not a typical situation, but we want you to be aware of them, and that's why we're practicing them so much. Okay, we're going to pause from our practice sheet right now, and then we're going to go to our notes. So you can stop this video and start the next one and get your notes out and ready to go.